In task 3, you pick a solution from task 1 or 2 with an absorbance that was approximately 0.5, and make sure you record the initial concentration of iron 3 plus and thiocyanate here of that solution, and you prepare the solution again and put them in different water bath, 10 degrees Celsius, 30 degrees Celsius, and 40 degrees Celsius. So you should record them here. This one should be around 10 degrees Celsius. This one is the room temperature, which you should have this value already from task 1 or 2, and the absorbance here. That absorbance should be around 0.5. This value here should be 30 degrees Celsius. Make sure you convert that into Kelvin, and this one is 40 degrees Celsius, and record the absorbance that you measured from the spectrophotometer. Here, this is 1 over T. Make sure you include the unit, which is 1 over K, and 1 divided by whatever values you have here, 4 of them. And the next thing you need to do is, just like task 2, look for the equilibrium concentration of the complex first, and make sure you use the graph from task 1, and same approach. You take the absorbance and divide it by the slope. And if you do that, you should be able to find the concentration of the complex at equilibrium. And again, if your slope from the graph is not between 4,000 to 8,000, use 5,000 instead for the slope. So make sure you find the concentration here, and for the equilibrium concentration of iron 3 plus and thiocyanate, use this equation again. You already have the concentration of iron 3 plus initially, and the thiocyanate solution initially recorded here, and you just solve for the equilibrium concentration of iron thiocyanate complex here. Using those values, you should be able to find the equilibrium concentration of iron 3 plus and the equilibrium concentration of thiocyanate. The next thing is the equilibrium constant. So same approach as task 2. The expression is here, and again use the same expression to solve the KEQ value. So this value is here, and those two values are here, so simply solve for them. And after you find the equilibrium constant, then take the natural log of that value, and you will end up with the values here. And you're told to graph natural log of equilibrium constant versus 1 over T. So this is your y-axis here, and this is your x-axis, and you will end up with a Van 't Hoff graph. So the next calculations you need to carry out are will help you to solve for the enthalpy and the entropy. So if you look at the equation here, this is a Van 't Hoff equation. So natural log of equilibrium constant equals mx plus b. So the slope here is negative delta H over the ideal gas constant. 1 over T is your X value, because remember that's the x-axis. And the y-intercept in this case is delta S, which is the entropy, divided by the ideal gas constant. So how do you solve for delta H? Well, you simply take the slope of the graph from task 3, this graph, and multiply by negative R. What about the entropy? So again, the y-intercept equals delta S divided by R. So to solve for delta S, or the entropy, you can take the y-intercept divided by, multiply by the ideal gas constant.